So the next question, which is asked in test series 2 from this subject process control, is 1 mark. Go through the question. So the given transfer function of a system is 16 by s square plus 1.6 s plus 16. So with this system we need to get a damping ratio of 0.8 when we are adding a derivative rate feedback for this system. So now with for the given system, the question is, for a given system with the transfer function, we need to make zeta equal to 0.8 by adding a derivative rate feedback system. So what should be the value of the rate feedback? So given transfer function is 16 by s square plus 1.6 s plus 16. From this we compute the natural frequency omega n as 4, and the zeta is nothing but 2 zeta omega n equal to 1.6. If I substitute omega n and calculate zeta, it comes as 0.2. So you can clearly see the actual zeta of the system is 0.2 without adding derivative rate feedback. So we need to calculate, we need to achieve a zeta of 0.8 by adding a derivative rate constant. So the overall transfer function when we add a derivative rate feedback is omega n square by s square plus 2 zeta omega n plus omega n square kt into s plus omega n square. So this will be the transfer function of the system when we add a derivative rate feedback to a second order system, for a given second order system. So you can clearly see 2 zeta dash omega n equal to the new quantity, which is 2 zeta omega n plus omega n square kt. So when I divide by the equation by 2 omega n, we get zeta dash as zeta plus omega n kt by 2. So the new zeta should be 0.8. So the actual zeta of the system is 0.2 plus omega n we know 4 times kt by 2. So with this equation we can calculate kt as 0.3. So to achieve a zeta of 0.8 from 0.2, we need to have a derivative rate constant of 0.3.